Introduction. Rahul and his father are watching news on the television. The news about the changing climate is going on the television. Suddenly, Rahul asked his father, "Dad, I want to ask you something." "Sure, son." "Dad, nowadays, why the climate is changing?" "Son, climate is changing because of global warming." "Global warming?" "Dad, I don't have much idea about that. So please tell me about this." "Okay, son. Global warming is the rise in the average temperature of the Earth's atmosphere and oceans. Some greenhouse gases like carbon dioxide traps the heat radiation in the Earth's atmosphere. Due to increasing emission of these gases, average temperature of Earth's atmosphere and oceans are slightly increasing. And that is the reason behind the climate change." "Okay, father, I got the answer of my question, and I want to know more about this." "Son, to know more, you have to study the environmental chemistry." Today, we will study more about the environmental chemistry. Objectives. At the end of this lesson, you will be able to define environmental chemistry, know about environmental pollution, define atmospheric pollution, explain tropospheric pollution, define greenhouse effect, define acid rain, explain stratospheric pollution, define water pollution. Understand sources of water pollution, define soil pollution, understand sources of soil pollution, analyze industrial waste, know about strategies to control environmental pollution, define green chemistry. Definition. Environmental chemistry is the scientific study of the chemical and biochemical phenomena that occur in natural places. It can be defined as the study of the sources, reactions, transport, effects and fates of chemical species in the air, soil and water environments. In environmental chemistry, we identify a pollutant and its interaction with the environment, its bad effects, and find out a way to minimize them. Environmental pollution. Environmental pollution is a global crisis encompassing both developed and developing countries. Excessive craze for program in agriculture, industry, transportation and technology are taken as index for development of any nation. Such activities are leading to an imbalance in our environment. Before proceeding, we must be aware of some basic terminologies. Pollutants and contaminants. Pollutants. Some substances present in nature in greater quantity than natural abundance due to human activities are termed as pollutants. These pollutants have inverse effect on environment, particularly in biosphere. For example, lead, mercury, carbon dioxide, etc. Contaminant. These substances do not occur in nature but added to the atmosphere by human activities. For example, chlorine, chlorofluorocarbon, etc. Receptor, sink and pathways. Receptor. The medium which is affected by a pollutant. For example, living bodies, human bodies, etc. Sink. The medium which retains or destroys a pollutant is known as sink. For example, oceans are the sink for atmospheric carbon dioxide. Pathways for pollutant. The mechanism by which it is distributed into the environment from the source is known as pathways for pollutant. For example, emission of gases from automobiles. Dissolved oxygen, chemical oxygen demand and biochemical oxygen demand. Dissolved oxygen. Oxygen, which is vital for metabolic activities for aquatic life, is an important parameter for quality of water. For example, drinking water contains 4 to 6 mg of dissolved oxygen per liter. Chemical oxygen demand. It is a parameter to determine organic matter present in water. Biochemical oxygen demand. It is also a parameter to determine the quality of water. It is measured by the quantity of oxygen utilized by suitable aquatic microorganisms during a 5-day period. Atmospheric pollution. Earth is surrounded by a thick envelope of gases called atmosphere. Atmosphere is divided into different layers depending upon the distance from the sea level. The nearest region, which extends to the height of about 10 km from the sea level, is called troposphere. It contains about 80% of total mass of air and almost all water vapors. It refers to air pollution. The region above the troposphere between 10 to 50 km is called stratosphere. The stratosphere contains gases like nitrogen, oxygen and ozone. It refers to ozone layer and its depletion. Tropospheric pollution. Tropospheric pollution occurs due to the presence of undesirable solid or gaseous particles in the air. There are two types of pollutants which cause tropospheric pollution: gaseous air pollutants and particulate pollutants. Gaseous air pollutants. These are oxides of sulfur, nitrogen and carbon, hydrogen sulfide, hydrocarbons, ozone and other oxidants. Particulate pollutants. Particulate pollutants are the minute solid particles or liquid droplets in air. These are present in vehicle emissions, smoke particles from fires, dust particles and ash from industries. Oxides of nitrogen and sulfur. Pollutants. Oxides of nitrogen. The main oxides of nitrogen which are responsible for air pollution are NO and NO2. Main source of nitrogen oxides is human activity such as burning of fuel. The main reactions are: NO reacts with hemoglobin in our blood and oxygen carrier property of blood is lost. But NO2 is more harmful. Breathing of NO2 causes lung inflammation, bronchiolitis, even death. Oxides of sulfur. The main source of oxides of sulfur is roasting of pyrite ores, burning of petroleum products. The main reactions are: volcanic eruption and forest fire also contribute SO2 in the atmosphere. Oxides of sulfur mainly affects respiratory tract, causing severe irritations, bronchial spasm. They also form acid rains. It is most dreaded air pollutant as it forms photochemical smog. Oxides of carbon. Pollutants. Carbon monoxide. Incomplete combustion of fossil fuels generates CO, particularly in blast furnace and automobiles. CO is a poisonous gas and reacts with hemoglobin present in blood, producing strong complex carboxyhemoglobin. Thus, oxygen carrier property of blood is lost. High concentration of carbon monoxide in air causes respiratory problem, fatigue, and even death. Carbon dioxide. Major portion of CO2 is produced during burning of fossil fuels. Atmospheric CO2 is consumed during photosynthesis, releasing oxygen. Excess CO2 in the atmosphere causes global heating, known as greenhouse effect. Example on gaseous air pollutants. Let's take an example on gaseous air pollutants. The presence of CO reduces the amount of hemoglobin available in the blood for carrying O2 to the body cells. Justify the statement giving reasons. Let's see the solution. CO combines with hemoglobin of red blood cells about 300 times more strongly than O2. It forms a complex named carbonyl hemoglobin which doesn't carry O2. Thus, the O2 carrying capacity of hemoglobin gets reduced. Greenhouse effect. In cold countries, plants of tropical countries are cultured in glass houses. Glass permits UV light to enter through it, but the reflected light cannot pass through glass. Thus, a greenhouse remains warm, which is suitable for growth of plants of tropical region. An envelope of carbon dioxide, moisture, clouds exactly do the same thing. They allow to pass UV light to the Earth's surface, but hinders the passage of reflected infrared radiations to the upper atmosphere, causing global heating. Greenhouse effect has a long-range impact on ecological balance, such as rise in sea level due to partial melting of ice in the polar region. Such increase in volume of water may result in loss of many coastal areas, islands, even mainland. Acid rain. Rain occurs when water vapors condense in clouds and fall on Earth. As it begins to fall, it is neutral, having pH value equals to 7. In clean air, rain picks up materials that occur naturally, such as dust, pollen, some carbon dioxide, and other chemicals produced by lightning or volcanic activities. These substances make the rain slightly acidic, having pH value nearly equals to 6. When the rain falls through polluted air, it comes across chemicals such as gaseous oxides of sulfur, oxides of nitrogen, mists of hydrochloric acid and phosphoric acid, etc. These substances dissolve in falling rain, making it more acidic than normal, with pH ranging between 5.6 to 3.5. This rain is known as acid rain. Particulate pollutants. Particulates pollutants are the minute solid particles or liquid droplets in air. These are present in vehicle emissions, smoke particles from fires, dust particles, and ash from industries. Particulates in the atmosphere are of two types: viable and non-viable. Viable. These are minute living organisms that are dispersed in the atmosphere. Example: bacteria, fungi, molds, algae, etc. Non-viable. These particulates are classified according to their nature and size. Non-viable particulate pollutants. Smoke. It consists of solid or mixture of solid and liquid particles formed during combustion of organic matter. For example, cigarette smoke, smoke from burning of fossil fuel, oil smoke, etc. Dust. It composed of fine solid particles produced during crushing, grinding and attribution of solid materials. For example, dust from woodworks, pulverized coal, and fly ash from factories, dust storms, etc. Mists. These are produced by particles of spray liquids and by condensation of vapors in air. For example, sulfuric acid mist, herbicides and insecticides. Fumes. These are generally obtained by the condensation of vapors during sublimation, distillation, boiling and several other chemical reactions. For example, organic solvents, metals and metallic oxides form fume particles. Smog. Combination of smoke and fog is generally known as smog. Various types of solid suspended air pollutants combined with gaseous air pollutant and moisture in stagnant atmosphere causes smog formation. Generally at the early hours of the day or in evening is known as smog. Smog causes severe throat infection, affects respiratory tract and cardiovascular system. Photochemical smog. Photochemical smog is much more dangerous from ordinary smog. It is brown in color, observed in daytime in cities having high population densities. They are formed by photochemical reaction between a hydrocarbon, other air pollutant and particulates present in the atmosphere. During metabolic activities of plants, bacterial activity, and anaerobic decomposition of organic matter, a large amount of hydrocarbon is emitted into the atmosphere. Most dangerous product due to photochemical reaction is peroxyacyl nitrate, PAN. Photochemical smog contains hazy fumes which irritate eyes and lungs, lead to cracking of rubber articles. Ozone layer. At about 20 to 25 km above the sea level, a thin layer of ozone is present. It is produced by photochemical reaction of oxygen with UV light. Ozone can absorb most harmful UV radiation and protects the living bodies on Earth. In absence of ozone layer, living bodies will suffer serious radiation hazards such as skin cancer. Ozone hole. The chlorofluorocarbons, which are widely used in refrigeration and perfume industries, damages ozone layer. Thinning of ozone layer, particularly in polar region, is known as ozone hole. O3 is destroyed when it comes in contact with CFC through the formation of free radicals. Therefore, CFCs cause extreme pollution by destroying ozone layer, creating ozone holes which permits UV radiations to reach Earth's surface, causing skin cancer and damaging plant and animal life. Water pollution. Water pollution is the contamination of water bodies. It occurs when pollutants are discharged directly or indirectly into water bodies without adequate treatment to remove harmful compounds. Water pollution affects plants and organisms living in these bodies of water. Natural phenomena such as volcanoes, algae blooms, storms and earthquakes also cause major changes in water quality and the ecological status of water. Sources of water pollutant. Sewage, industrial water, waste from houses, runoff water from agricultural lands, etc. contain biodegradable substance which enhances bacterial activities. Thus, dissolved oxygen in water decreases. Sewage water. It is the main source of water pollution. It is a carrier for pathogenic microorganism which causes extreme harm to public health. The water-borne diseases like typhoid, dysentery, cholera, hepatitis, etc. are results of use of polluted water. Fertilizers and insecticides. Excessive use of fertilizers change the soil character, and some of the insecticides are non-biodegradable, causing long-term harm in our ecological system. Other factors causing water pollution. Detergents. When detergents get mixed with the water body through drainage from domestic households, a thin layer of emulsion is formed on the upper surface of water. This emulsion inhibits dissolution of atmospheric oxygen in water. Oil floating on sea surface. Leakage of hydrocarbon oils from oil tankers producing an oily layer on sea surface also cause serious threat to aquatic lives. Oily layer gradually reduces dissolved oxygen in sea water and the aquatic life gets less oxygen for their respiration. Thermal pollution. In hydel projects, cold water is drawn from river sources and hot water is discharged in the same river. Thus, temperature of the river water is enhanced, affecting the aquatic lives. Soil pollution. Any factor which deteriorates the quality, texture and mineral content of the soil or which disturbs the biological balance of the organisms in the soil is referred to as soil pollutant. It is typically caused by industrial activity, agricultural chemicals or improper disposal of waste. The most common chemical involved are petroleum hydrocarbons, polynuclear aromatic hydrocarbons, solvents, pesticides, lead and other heavy metals. Soil pollution has adverse effect on the plant growth. Sources of soil pollution. Industrial waste. Waste from different industries and radioactive waste from thermonuclear power station pollute soil with undesirable substances. Use of pesticides. Pesticides are used to destroy harmful bacteria, pests, weeds, and fungus which inhibit plant growth. These pesticides remain in soil for a long time and destroy the useful bacteria present in the soil and some insects which help pollination. Other factors causing soil pollution. Domestic waste. Broken glass articles, plastic, ash, etc. are the main soil pollutants. Chemical fertilizers. Excessive use of nitrogenous and phosphatic fertilizers also causes pollution to soil. Excessive fertilizer destroys some useful bacteria, hinders the absorption of trace elements by plants. Industrial waste. Industrial activities always produce some inorganic and organic wastes which are directly disposed in water bodies. This causes serious water pollution and affect the general health of aquatic animals. Effects of pollutive action of different metals are: mercury. Waste from alkali chlorine industry is the main source of mercury contamination in water. Mercury is dangerously poisonous for our body and it damages nervous system and kidneys. Arsenic. Excessive withdrawal of groundwater increases the concentration of arsenic in the rest part of water. It causes serious type of incurable skin disease leading to death. Cadmium and lead. Industrial waste. Cadmium. Metallurgical process of zinc, copper, lead and factories which produce nickel-cadmium rechargeable batteries are main source of cadmium pollution. Intake of cadmium polluted water produce vomiting tendency, damages kidney, liver and anemia. Lead. Wastes obtained from extraction of lead, leaded petrol, paint industry when mixed with water bodies cause lead pollution. Accumulation of lead in our body causes loss of appetite, headache, insomnia, constipation, etc. Strategies to control environmental pollution. Environmental pollution control means the control of emissions and effluents into air, water or soil. Without pollution control, the waste products from consumption, heating, agriculture, mining, manufacturing, transportation and other human activities will degrade the environment. The management of waste is very important. The improper disposal of household, medical, agricultural, industrial and mining waste is the major cause of environmental degradation. Recycling is processing of used materials into new products to prevent waste of potentially useful materials and reduce the consumption of fresh raw materials. In reuse method, to use an item again after it has been used. Non-biodegradable wastes like polythene bag, metal straps, etc. choke the sewers and cause inconvenience. All domestic wastes should be properly collected and disposed. Green chemistry. Green chemistry is a philosophy of chemical research and engineering that encourages the design of products and processes that minimize the use and generation of hazardous substances. The focus is on minimizing the hazard and maximizing the efficiency of any chemical choice. The three key developments in green chemistry are: use of supercritical carbon dioxide as green solvent, use of aqueous hydrogen peroxide for clean oxidations, use of hydrogen in asymmetric synthesis. Example of applied green chemistry is supercritical water oxidation on water reactions and dry media reactions. Concepts of green chemistry. the design of processes to maximize the amount of raw material that ends up in the product, the use of safe, environment-being substances, including solvents whenever possible, the design of energy-efficient processes, the best form of water disposal, not to create it in the first place. Did you know? An estimated 14 billion pounds of trash, much of it plastic, is dumped into the world's oceans every year. Each year, there are about 250 million cases of water-based diseases, resulting in nearly about 5 to 10 million deaths. Large hog farms emit hydrogen sulfide, a gas that most often causes flu-like symptoms in humans, but at high concentrations can lead to brain damage. Engine exhaust contains more than 40 hazardous air pollutants. Summary. Let us summarize what we have learned. Environmental chemistry is the study of the sources, reactions, transport, effects and fates of chemical species in the air, soil and water environments. Some substances present in nature in greater quantity than natural abundance due to human activities are termed as pollutants. Chemical oxygen demand is a parameter to determine organic matter present in water. The nearest region, which extends to the height of about 10 km from sea level, is called Troposphere. An envelope of carbon dioxide, moisture, clouds allow passing UV light to the Earth's surface, but hinders the passage of reflected infrared radiations to the upper atmosphere, causing global heating. Fumes are obtained by the condensation of vapors during sublimation, distillation, boiling, and several other chemical reactions. Photochemical smog is formed by photochemical reaction between a hydrocarbon, other air pollutant, and particulates present in the atmosphere. Any factor which deteriorates the quality, texture, and mineral content of the soil, or which disturbs the biological balance of the organisms in the soil, is referred to as soil pollutant. Green chemistry is a philosophy of chemical research and engineering that encourages the design of products and processes that minimize the use and generation of hazardous substances.